Chapter 8, Section 8 in the 7th grade workbook is entitled Angles in Polygons. Now the directions for 1 through 6 are all the same. They're asking me to find the unknown measures in each polygon. So this top section is actually kind of nice because these top 3 questions here are all triangles. And the one important fact that you need to know here to find the missing angle is what all the angles add up to. Well, no matter what type of triangle it is, no matter what type of sides it has, or if it's acute or right or obtuse, one thing is true. If it's a triangle, 3 angles in the triangle have to make 180 degrees. So I'm always going to be finding what the third angle is that's going to make the other 2, when I add it to it, add up to 180. So let's go ahead and take a look here at number 2 in the middle. I've got a 14 and a 30, and I've got to figure out how much more I would need to get to 180. Well, that's some simple arithmetic. I'm just going to do 180 minus the 30 that I already have, which is 150, minus the 14 I already have, which is 136. So the angle with the question mark must equal 136 degrees. Indeed, 136 plus 14 plus 30 is how I add up to 180. And you'll do the same thing there in 1 and 3. Now as we take a look at this bottom set here is all quadrilaterals. Well, quadrilaterals all have one thing in common, no matter what quadrilateral it is. Quadrilaterals, like a square or rectangle, are examples of quadrilaterals, always add up to 360 degrees. So here I'm looking for to make the sum total of the 4 angles add up to 360 degrees. So if we go ahead and take a look at the trapezoid shape there at number 5, I've already got 133 and 62 and 50. So I'm going to take 360 and subtract the 133 that's there, subtract the 50 that's in the bottom right corner, subtract the 62 that's in the lower left corner, and when I do that, I get 115. So the angle that's marked question mark has to be 115 degrees. And indeed, 115 plus 133 plus 62 plus 50 adds up to 360 degrees. And you'll be doing the same thing in question 4 and 6 there, trying to find a way to make the sum total of the angles make 360 degrees. Now, as we go down to the bottom here, slightly more complicated here, now they're asking me to divide each polygon into triangles to find the sum of its interior angles. Remember, as you saw in the instruction today, this is a process known as triangulation. And I can probably best show it to you in number 10. You saw it in class, though, with a rectangle. The process of triangulation means you pick a corner in the shape. So I'm going to pick this bottom right corner. And you draw a line to every other corner in the shape. Now, obviously, to this corner here and to this corner here, those lines already exist. But to this corner over here, where I'm drawing the X right there, I don't have anything there. So I'm going to go ahead and draw a line over to that corner. And what happens there is I chop my shape into 2 triangles. Well, that helps me because I know that a triangle has to make 180 degrees. The angles of the triangle have to make 180 degrees. So if I've got 2 of those triangles, well, if each one's 180, 2 triangles at 180, 2 times 180 is 360 degrees. So the angles in the shape there have to make 360 degrees. And that's the process they teach you to go about here in solving the rest of these questions. Now, from that process, you can derive the formula to solve this, which will probably make your life a whole lot easier. The formula here says n minus 2 times 180 is a way I can find the sum of the angles in any polygon. N in the formula represents the number of sides. So if we go ahead and take a look at this one here, the example we've already solved, we had 1, 2, 3, 4 sides in the shape here. So I would change n into 4 and solve. Well, if I change n into 4, 4 minus 2 is 2, and 2 times 180 gives me 360, which is exactly what I found. Now, as you can see, this part here worked out to be 2. Well, what do we know 2 to be? Well, 2 was the number of triangles we generated here. We generated 1, 2 triangles in this shape. So all this is it's really figuring out how many triangles you're going to generate and then multiplying it by 180 because one individual triangle is 180 degrees. And that's how we're finding the sum of the angles. So if we come over here, for instance, at number 9, we have 1, 2, 3, 4, 5 sides. Well, by formula, I'm going to take and change n into 5. 5 minus 2 is 3. 3 times 180 is 540. Well, let's see if we can vet that out and make that happen. I'm going to go ahead and pick a corner in my shape. I'm going to pick this one here that I've put between side 1 and 5. Draw a line to every other corner. Well, obviously, this one's already there, and this one's already there, but I've got this line here, and this line here, and as you can see, how many triangles do I end up generating? Well, it's no surprise because we figured it out from the formula. There ends up being 1, 2, 3 triangles. 3 triangles at 180 makes 540, exactly as we solve. So you can draw the triangles here to solve these other 4 questions, or you can just dump the numbers into the formula, and the formula will tell you the sum of the interior angles. All right, let's go ahead and take a look at the last question here, number 13. It says a stop sign has the shape of an octagon, a regular octagon at that. What is the sum of the interior angles of a stop sign? So, since it's an octagon is an 8-sided shape, we're going to go ahead and use the formula and change n into 8. So I'm going to do 8 minus 2 times 180, which is, of course, the same as 6 times 180. That's me using the order of operations there. And when I do 6 times 180, I end up with a solution of 1,080 degrees. So the sum of the angles of a regular octagon is 1,080 degrees. Now, where they might take this type of question is then to ask you, find the measure of one angle of the octagon. Well, the only way they can get away with that is because they said right here it's a regular octagon. Remember, regular means that all the sides in the shape are the same and all the angles in the shape would be the same. So if we know that they all add up to 1,080 degrees, and we know that each one has to be the same, if I was asking you to find one angle in the octagon, which they're not, but they might eventually, then what I would do is take that solution and divide by 8, because there's 8 angles in the shape. And when I take 1,080 and divide by 8, that's 135. So one angle in the regular octagon measures 135 degrees.